On average, Mercury is the closest planet to Earth, not Venus, not Mars. You'd think it would be easy to reach. It took one spacecraft 6.5 years to get there, and that mission was considered a success. The problem isn't distance, it's the Sun. Most people imagine the solar system as a set of tidy diagrams, planets evenly spaced, everything reachable if you point a rocket in the right direction. That picture is wrong. Not slightly wrong, fundamentally wrong. And once you understand why, the distances in this solar system stop feeling like numbers and start feeling like walls. Start with the Moon, because that's the only comparison actually in our bones. Apollo 11 took 3 days to get there. 3 days to cross 384,000 kilometers. People watched it and thought, this is how space travel works. We go, we arrive, we come back. Venus comes first. It's the second planet from the Sun, nearly the same size as Earth, once thought to be Earth's twin. In 1962, NASA's Mariner 2 became the first spacecraft to reach another planet, 109 days of travel. What it found was not a twin of Earth. Surface temperatures of 465 degrees Celsius. Atmospheric pressure 90 times greater than at sea level. Venera 13, the longest surviving spacecraft ever to land there, lasted 127 minutes before the heat and pressure destroyed it. Venus is close. It is not welcoming. Mars is 146 times farther away than the Moon at closest approach. That's not a typo. 146 times. That alignment only happens once every 26 months. Miss that window, and you wait over 2 years for the next one. The fastest missions to Mars took months. Modern missions take 6 to 9, and that's just to get there. No human being has ever traveled beyond the Moon. But here's where it gets genuinely strange. Mercury orbits closer to the Sun than any other planet. And yet, the Messenger spacecraft, launched in 2004, took 6.5 years to reach it. It flew past Earth once, past Venus twice, and past Mercury itself 3 times before finally entering orbit. It flew past its own destination 3 times. The reason is the Sun's gravity. The closer you get to the Sun, the faster everything moves, and the harder it becomes to slow down enough to stop at a planet rather than fall deeper into the star's gravity well. You can't aim at Mercury and fire your engines. You have to bleed off speed constantly, using other planets to reshape your trajectory. Bepi Colombo, launched in 2018 by ESA and JAXA, requires 9 gravity assists over 7 years before entering Mercury orbit in 2026. Distance is only part of the problem. The further out you go, the environment itself becomes the obstacle. Jupiter is a different problem entirely. Juno left Cape Canaveral in August 2011 and didn't reach Jupiter until July 2016. 5 years. When it arrived, the spacecraft carried a titanium vault around its electronics. Because Jupiter's radiation environment is so intense, it would destroy unshielded systems within days. Scott Bolton, Juno's principal investigator, described it as flying through a particle accelerator. Every spacecraft leaving Earth is already traveling around the Sun at over 100,000 kilometers per hour before its engines even fire. Reaching another planet is not like driving somewhere farther away. It's more like jumping between moving trains traveling at different speeds while the distance between them constantly changes. You don't aim at where a planet is. You aim at where it will be when you arrive. Miss the angle by a fraction, and you miss by millions of kilometers. And you cannot turn around. A human crew at Jupiter's distance, unshielded, would receive a lethal radiation dose in under 10 minutes. They cannot design that away. Saturn took longer. Cassini-Huygens launched in October 1997 and arrived in July 2004. Nearly 7 years. The mission ran until 2017, when NASA deliberately crashed it into Saturn's atmosphere at 113,000 kilometers per hour. Not because it failed, because the fuel was nearly gone, and the team didn't want an uncontrolled spacecraft contaminating Enceladus or Titan, moons that may harbor subsurface oceans. When the signal finally went silent, The team in Pasadena said nothing for a long time. Beyond Saturn, the distances stop feeling planetary. They start feeling like something else entirely. Voyager 2, the only spacecraft ever to visit Uranus, took 8.5 years for a flyby lasting only hours. Since then, no spacecraft has returned. If a mission launched in the early 2030s, it won't arrive until 2044. And then it gets quieter still. Neptune is farther still. Voyager 2 reached it in 1989, 12 years after launch. No other spacecraft has been sent there since. Neptune's largest moon, Triton, orbits backwards, almost certainly captured from the outer solar system. Scientists believe it may hide a subsurface ocean. We have one close-up survey of Neptune, a flyby. Ours, 1989. And then there's Pluto. When New Horizons launched in January 2006, it was traveling at 58,000 kilometers per hour, the fastest launch velocity ever achieved by a human-made object at that point. New Horizons arrived in July 2015. The data it collected during a single afternoon of close approach took 16 months to fully transmit back to Earth, because the signal was crossing 4.8 billion kilometers of space. Space travel doesn't happen in movie timescales. We have explored every major world in this solar system exactly once, most of them only briefly. There is one destination we haven't mentioned, the one everything else orbits around. Paradoxically, the Sun is one of the hardest places in the solar system to reach. Earth is already moving around it at over 100,000 kilometers per hour. To fall into the Sun, a spacecraft first has to cancel almost all of that sideways motion. We cannot do that directly. Parker Solar Probe spirals closer by using Venus to bleed away speed over years. Even falling into the Sun requires taking the long way around. What these missions share isn't just distance, it's time. Real human time. The engineers who built Voyager are retired or gone. Entire careers spent waiting for data from places no one will visit again. The deeper tension is one planetary scientists discuss carefully. Chemical rockets are approaching their physical limits. Nuclear thermal propulsion, ion drives, solar sails, these exist in laboratories. None are close to carrying humans to the outer planets. With our current best technology, a crewed Mars mission takes 6 to 9 months one way. A crewed mission to Jupiter is not survivable due to radiation. Neptune would take decades, and whoever launched the crew might not be alive when they arrived. The solar system is not small. We just drew the map that way.